project is to make a map of the Caribbean and quantify carbon sequestration by seagrasses. So how much carbon can be taken up by seagrasses? The thought is that that will help fight climate change, take some carbon out of the atmosphere. Are you extending the drop buoy?
Yeah.
Thank you. Looks pretty clear today. $60, $50. Drop.
At the bottom.
Perfect. Wow, these are the cheapest mesh bags there are now.
We are taking a hammer, vice grip, these red caps. It doesn't matter the color. This rope to take the cork off the soil. This come along.
Has all these holes for subsampling. So once it is filled with sediment, we will take little syringes and take little samples out of every second hole. But when we take the core in the first place, we have to cover these holes because otherwise all the sediment would run out. So for that, we will use the duct tape. And our goal is to just cover these holes and make the duct tape fit very, very tightly. Because if there are any holes or any wrinkles in the duct tape, then when you drive the core down into the sediment, it will catch and maybe remove the duct tape and mess up the whole core. So one thing that helps attach it is to clean the core well before. So we would use some fresh water. Meter core. We had 12 of these produced by Machine Shop, and they are being provided to all of our partners. So we send these out, or we bring them with us. Alright, so now we have to tape the end in this direction to give it a little bit more stability. Alright, and then we do the same on the top. So we want to make sure we know where the first opening is and that we drive the core into the sediment only up to slightly above that hole. If we drive it deeper, then we're not going to be able to sample the top layer of the sediment. So we want to somehow mark the area just above the top hole. So when we are driving the core down, we see immediately, okay, we have to stop here, that's it. For that we just use the tape again and wrap it sideways around the top. That should be good. And now we need the plunger. This plunger, it fits perfectly into the core tube. And if it doesn't fit perfectly, it's possible to adjust the width a little bit with this nut. But it will stay in the core. At first on the bottom, and then when we drive the core into the sediment, it's gonna rise up, and once we're done, it will stay on top and seal the core. The chain is going to be attached to a tripod underwater, so the plunger stays always on the sediment surface, right there. And this is our core tube prepared.
A piece of wood with weights in the corners. Heat person's work. One person has to be hammering, and the other person has to make sure that the tripod is staying in place.
Barrel is driven into the sediment around the plunger. As the sediment pours down, we attach the chain with the vice grip to the core, and then we pull the whole thing out. These vials that are pre-weighed with no caps and already labeled. We have enough vials for every subcore. We use these syringes to record exactly the volume of sediment we take from the core. Then we transfer that into the vial. And so we have to write down the vial number and the core volume and the depth interval that we subsampled. So these data sheets are standardized for this. And so there's a magic moment. See if the core actually works out. If the water is still in the core, that's a good sign, because that means that we didn't lose a lot of sediment with the water and so on. So this is where our sediment layer starts, right here. So let's tape measure to this. This is our 0. This is the sediment surface. And then we count from there down. Okay. So this is at 2.5. We sample all the intervals in the top up to 10 centimeters or so, and then we go by every second. So we want to capture the variability or variation in sediment, and usually it varies the most in the top 10 centimeters. The deeper layers are interesting because you're looking into deep time. It's hundreds to thousands of years, and then you can check what happened back then. And the top layers are more the short-term processes. Within the core you might be seeing some shells of specific animals. It's mostly the shells that would survive in the core.
4.5.
So we did already collect cores from very different locations. Also seagrass beds, but we are trying to capture a diversity of different types of seagrass habitats. So we already cored near shore, where we mostly had muddy sediments, a lot of nutrients and productivity. And now we are out here at the reef in oligotrophic waters, where it's mostly broken down shell material that we find. And so we can expect the types of carbon and the amounts of carbon that we find in these cores over here to be very different from the ones in other cores. And if we want to characterize carbon sequestration across the Caribbean, we have to try to capture all different types of habitats. So we did pre-weigh the vials so that we know the dry weight of it, and then the sample that we put in there, we're going to directly dry, and by the difference of the weight of the wet sample in the vial and the dry sample in the vial, we know how much water there is in the sample, and we can say something about the density of the sediment. And it doesn't really matter how much material we take, it has to be enough so we can analyze it. But it's very important to know how much it was so that we can calculate the density. We plan to do a series of analysis, so we need a lot of sample. Being very careful with transferring the sample from the syringe into the vial, because everything, all the material that we lose is going to be error in our density calculations. The sediment is pretty homogeneous. So one interval looks very much the same as the other in terms of coloration, grain size, and so on. So we might just do every second. So every sample that we take now is representative of a larger part of the core than the samples up there. So we are going to determine the percent organic carbon in there and the percent inorganic carbon, so shell material. We will also test nutrients, so phosphorus and nitrogen, again in percent. And then we will do stable isotope analysis of carbon, nitrogen, which is going to tell us a little bit about where the carbon comes from. So is it seagrass material, or is it maybe, does it come from land? So this doesn't allow us to continue coring. Biomass course over here with above ground biomass of seagrass, so leaves and then roots and rhizomes. And we collect 8 of these per site. So every second quadrat that we survey, we collect these biomass cores.
Thank you.